Hey YouTube, welcome back. Today we have this problem. We have a JavaScript problem. We continue our series in JavaScript fundamentals. Today we talk. It will be like today we talk about important aspects in JavaScript. We are say giving a positive integer called millis and write an asynchronous function that sleeps for some milliseconds, like some amount of seconds. It can resolve any value. So we have the input will be the millis if it's 100, so the function should sleep for 100, and yeah, and after that try to resolve something. So basically I just want to show something that the solution for this problem is really easy. That we, if we want to do it like that, we could return a new promise, and just if it's resolve we set timeout out, and that will be have the resolve value, and we just send it after the millis, and that's it. Basically just like that. But what makes this problem pretty interesting is how much of functionality that was built in to make this function work. Basically, we'll talk about how the JavaScript work in asynchronous programming. So before we start, if we don't know what asynchronous programming is, it's basically asynchronous programming is programming paradigm and technique used to handle tasks that may take long time to complete, such as fetching data from server, reading from file, or making API calls. It allows programs to continue executing other tasks without waiting for the completion of the time consuming operation. So this is what is asynchronous programming. Okay, so basically the problem talks. We talks about the. You should be familiar with what is asynchronous is. Right now also we focus on something different, something else also, which is set timeout. And basically, the set timeout is a built-in JavaScript function that allows you to schedule the execution of a function after a specified delay. It's commonly used for introducing a delay in code executing or triggering a function to run once after a specific amount of time. So we have the callback and we have the delay. So this is the callback and the others. The other argument is the actual delay. And we want to talk about something else, which will be something called the event loop. And this is one of the most important thing, because the event loop is fundamental concept in JavaScript that governs the execution order of asynchronous operation, and manages the responsiveness of JavaScript runtime environment. It ensures that JavaScript can handle tasks efficiently, such as handling user interaction, network requests, and timers, while remaining responsiveness in new events. Basically, I don't know if you know or not, but JavaScript is a single-threaded language. So basically, all the operation has been served by one thread. So basically, mean it executes one piece of code at a time. However, it can handle an asynchronous operation through non-blocking mechanism, thanks to the event loop. Basically, if you want to simplify, first of all, we have the callback stack. The callback stack in JavaScript maintain a call stack to keep track of a function calls, their execution context. When a function is called, it is added to just give me a minute, because I wanna show you this I want to show you this image because it's quite important to look at this image. Okay, so let's just talk about this image. Let's just delete this. Miro sometimes just fail off like that. Just it's weird. Okay. I know this is called Node.js, but like just assume this is why it's not why it's not oh, it's not so good. Wait a minute. No, this is not good. This is not good. Yeah, let's copy it again. Okay. This is way more better. Okay, so if we want to talk about the event loop, so basically we have the call stack and basically you can just call we have the call stack, and the JavaScript maintains all call stack to keep track of a function calls, their execution context. So when a function is called, it added to the top of the call stack, and when it completes, it removed from the stack. And just 1 minute. Yeah. Okay. So I just want to search for a better image for us to use. Yeah, this one is way more better. This one is way more better. Yeah. Okay. This one is way more better. And okay, where we are. So I just refresh. Okay. So and if you wanna go back to the event loop again, so basically you have the call stack and sorry, I'm just trying to have some noise here. So basically, let's talk about again. We have the call stack in JavaScript that uses the call stack to keep track of the functions calls, as you can see here. So we just try to keep track of the function calls. We have something called task queues, and this is asynchronous operations such timers, callbacks, things like that. We have our own main thing, which will be this is a callback queues, you can call it. After that, we have our own event loop. The event loop continuously checks the state of the callback stack and task queues. If the call stack is empty, it takes the first task from the task queue and push it onto the call stack in initiating its execution. We have non-block execution also, and this is the event loop allows JavaScript to handle multiple concurrent tasks without blocking the main thread. If an asynchronous task is being executed, the event loop can continuously processing other tasks from the task queue. We have something called micro tasks and things like that, but it's not important. You just for the sake of this video, it's just good to look at this diagram and just talk on it on a high level. Maybe in the future we could just get deep into it. And I guess the thing that we should also know about JavaScript in the set timeout and how actually the event loop works with how the event loop works. Basically, the set timeout functions plays a key role in this problem. It's method that calls a function or evaluates an expression after a specific number of milliseconds. In JavaScript, set timeout is used to delay execution of piece of code, as we said before. So basically, as we see here, this in this example that we can see, we are going to resolve calling the resolve function after after milliseconds of time. Basically, once the set timeout is called, the function runtime sets the timer, but then immediately continuously executing any following code. It does not pause or wait for the timer to finish, illustrating the non-blocking nature of JavaScript. After the specified delay 2 seconds, in this case, the callback function is added to the task queue. However, it's important to note that the callback function is not necessarily executed right at the moment, you know. So basically, like, you can imagine if there was a long process of operation blocking the main JavaScript thread in such a scenario. Even if the timer has a complete in the background, the callback function would still have to wait for the completion of the blocking task. This is because the event loop can only handle one task at a time, as we said before, and it's processing tasks in order, and they are queued. Maybe we talk about I guess we can talk about the asynchronously. I guess what else that we could be asked about. Maybe you can ask about the asynchronously and callbacks. Like, for example, I'll ask you, just tell me how the asynchronous and callbacks work. So basically, the set timeout is an example of asynchronous function in JavaScript. If you can say, when the set timeout function is called, it is starts to a timer and then immediately returns something, allowing JavaScript to runtime to continue executing other code without waiting for timer to complete. This is the non-blocking nature of JavaScript. I said non-blocking too much, but it is the question actually built on the non-blocking nature of JavaScript. Basically, once the timer complete, the callback function given to set timeout is added to the task queue. Basically, the event loop constantly checks the callback stack and task queue. When call stack is empty, it takes first. Okay, let's just go back here. So basically, event loop will all the time check the callback stack. Okay, when we have something in the call oh, I lost myself. I lost my words. What I was saying. Basically, JavaScript all the time check the call stack. It just take it, and actually it's sorry. I lost myself. So JavaScript runs a piece of code. Okay, when asynchronous operation is incurred, JavaScript sets it up and then continuously running the rest of the code. It doesn't wait for any asynchronous operation. It complete this asynchronous operations. It completes this asynchronous operation that might be running in the background. When asynchronous operation completes, its callback functions plays to the task queue. Okay, this one. And when once the call stack is empty, as you can, here it's not empty, but you can imagine it's empty. The event loop takes the first task from the task queue, and basically it pushes it into the call task, as you can see, which immediately executed. Okay, so we have this one task queue, When we found something, we take it, we push it to the call task, and after that, we're just firing immediately. And this process continuously with the event loop pushes the task from the task queue onto the call task, and whenever the task queue is empty, allowing JavaScript to handle multiple operations concurrently. Okay. So let's say this again because it's a pretty important thing. First of all, we know JavaScript runs a piece of code. We have a piece of code, okay? JavaScript is non-blocking, so JavaScript doesn't wait for anything. So when a synchronous operation is encountered, JavaScript, like set timeout, call back, fetch, anything, JavaScript basically sets it up and then continues running the rest of the code. Basically, JavaScript doesn't wait a synchronous operation. This asynchronous operation might be running in the background, okay? So, but not on the main JavaScript thread. Okay, so it's running in the background, but not on the thread because JavaScript is single thread. So basically, when the asynchronous operation completes, its callback function is placed into the task queue. So we have this one. This is the task queue or the callback queue. Call whatever you want. Okay. Second, once the call stack is empty, let's assume this call stack is empty. The event loop takes the first task from the task queue, okay, and the event loop takes the first task from the task queue and pushes it into the call stack, which immediately executed. So we have the event loop. Once it's empty, the event loop takes the first task in the task queue and pushes it in the call stack, which immediately fires it. Okay, so maybe like we do with APIs, call something timeout, so on and so forth. This process continuously with the event loop pushes tasks from the task queue into the call stack whenever the call stack is empty, allowing JavaScript to handle multiple operations concurrently despite being single threaded. So this is one of the most important things, how the event loop works and why it is important. Basically, this problem, in my opinion, is built on the event loop. Basically, maybe you got some other problem with the other question was promise and caching. So basically, the promise, because we use the promise, because there's something important you all should know here. When every single line of code in any JavaScript based interview, you will be asked about. So if someone asks you about the promise chaining, basically the promise chaining is a technique. Chaining is a technique in JavaScript that allows you to perform multiple asynchronous operation in sequence, which each operation starting when the previous operation has completed. The primary advantage of promise chaining it allows you to avoid the callback hill or pyramid of doom that can result from using nested callbacks and to handle asynchronous code. Instead, you can write asynchronous code that allows you it looks better actually. So like just give an example. What is the code? I'll give you an example here. So yeah, this is an example. Maybe you have you could be asked about finally. So basically in JavaScript, the promise over several powerful methods for handling asynchronous actions and their results. One of these methods is something called finally. Actually the finally method is built-in method in promise that is always executed regardless of whether the promise is fulfilled or rejected. This makes it an excellent place to put, like example, cleanup or stuff like that. So I'll just try to put another example. I will not delete these things because actually I will send a link to my solution so you can just look at these things also if you want. So yeah, that's it for this video. I guess the problem today was pretty long because we talked about a lot about heavy stuff. Specifically, we talked about the asynchronous programming and the event loop in general. So, and this is stuff pretty heavy to talk about. So that's it for this video. I hope my solution was quite good. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video. And see you in future problems.